Hello children, up to now you have completed the rational number chapter of 1.1 exercise and the definitions and also the properties. Now we shall continue for the next exercise, exercise 1.2. So what are the topics involved in this, what we are going to learn here, we shall see now here in this class. And listen students, and I have inquired many of you here. Many of you are not writing the FN in a proper manner. I think you have already remembered that how you have maintained the fair notes in 6th and 7th classes. You have to take a long rough notes and you have to write the headings properly, you have to make the margins and you have to mention each and every details what you are solving the problem. I have found some of the books you are writing as a rough notes itself. I said to maintain like as a fair notes. I want to see them like a fair notes. So it makes the subject to be very clear whenever you want to again observe them or you have to want to refer them. So whenever we come and we'll just we check that we should find there, it should be in the form of a fair notes. Not only my subject, other subjects also. So I feel you continue the same by writing in a proper fair notes. Now we shall see for the exercise 1.2. So represent these numbers on the number line. So first bit is we have to represent the given rational numbers on the number line. I will take the second one, minus 7 by 5. I think this type of representation already found in your 7th class. I think you have gone through this number lines and have known it already, but I want to repeat it again and make you to clear here. So I am taking the 0 here. So 1 by 5, 2 by 5, 3 by 5. So I am taking here the like fractions. Similarly on the left hand side, minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 5 by 5, minus 6 by 5, minus 7 by 5, minus 8 by 5. And we know that minus 5 by 5 becomes a minus 1 here. So, and I require to mention here is the minus 7 by 5. So, I am rounding up this. This is the, and how I am representing the minus 7 by 5 on the number line. Students, I think you understood how to represent those the rational numbers on the number line. If you consider for the 9 by 7, how you have to write? Similarly in this manner, take the like fractions, 0 here and some negative numbers, then 1 by 7, 2 by 7, 3 by 7, 4 by 7, so on for the 9 by 7 and round up for the 9 by 7 here. Next, similarly, second problem, minus 2 by 13, 5 by 13 and minus 9 by 13. So, draw a number line, write down all the like fractions and whatever the values is asking there, just round up them and mention them on the number line. Now, if you go for the third one, write 5 rational numbers which are smaller than 5 by 6. You already know the rational numbers less than 5 by 6. 4 by 6. Which problem it is? Third one. 4 by 6, 3 by 6, 2 by 6, 1 by 6, 0 or minus 1 by 6, so on. All these are less than 5 by 6 itself, and you have to mention only 5 rational numbers. And fourth one, find 12 rational numbers between minus 1 and 2. So 12 rational numbers between minus 1 and 2 for the solution. of all I am taking minus 1 and here is 2. So I am converting minus 1 in such a manner, minus 1 into 10 by 10 and here 2 into 10 by 10. See here I am adding multiplying 10 and also dividing by 10. So there will be no change here. So it becomes minus 10 by 10. It becomes 20 by 10. Now again I have converted them into like fractions. Now we can write easily that 12 rational numbers between minus 10 by 10 and 20 by 10. So rational numbers between minus 10 by 10 and 20 by 10 are minus 9 by 10, minus 8 by 10, minus 7 by 10, minus 6 by 10, minus 5 by 10, minus 4 by 10, minus 3 by 10, minus 2 by 10, minus 1 by 10. So on how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 and similarly you can write more 3 and you can finish there. He is asking just only 12 rational numbers. I think you understood very clearly this problem, students, and I want to move for the next problem. Now the fifth solution. Find a rational number between 2 by 3 and 3 by 4. Here we are given two rational numbers, 2 by 3 and 3 by 4. Here these are not like the fractions to write like previously one, and these are the unlike fractions. What we have to do to write the rational numbers between the two unlike rational numbers. So he is asking between. In between means nothing but middle value. Now to find out the middle value, take the average commonly. So then 2 by 3 plus 3 by 4 by 2. So, or one more way we can also take it. Other way, take the LCM of 3, 4. And these are 3, 4 both are co-primes to each other. So then we can directly write as 3 4s are 12. So 2 by 3 can be written as 2 by 3 into what we should multiply here to get the denominator 12. What should we multiply to 3 to get the denominator 12? It should be 3 4s are 12. We know clearly. So the same digit should be followed for the numerator. So it becomes 2 4s are 8 by 3 4s are 12. Now 3 by 4. Now 3 by 4 into the same procedure. What should be multiplied to 4 to get the denominator 12? It should be 3 by 3. It becomes 9 by 12. Now the digits are becoming 8 by 12 and 9 by 12. So these are the like fractions and we'll get a confusion. Is there any digit between this 8 by 12 and 9 by 12? Between these two rational numbers. But students, observe and recall that there will be infinite rational numbers will be there between any two rational numbers. There will be infinite rational numbers between any two rational numbers. Not to find the rational numbers between these two, I am taking the average. So the value between 8 by 12 and 9 by 12 is 8 by 12 plus 9 by 12 by 2. So 1 by 2 I am taking common here, and these are the like fractions. I am taking the denominator 12. 8 plus 9 is 17. 17 into 1 becomes 17 and 12 2s are 24. So, sorry students. the value between 2 by 3 and 3 by 4 is 17 by 24 is the value. The digit between the number between 2 by 3 and 3 by 4. And now the sixth solution, find 10 rational numbers between minus 3 by 4 and 5 by 6. The similar way you can follow up like this. Take the LCM of 4, 6 and make them here the equal denominators, and you can continue further. The similar way you can get the answer. Now we are going to see a new topic for you, the decimal representation. The decimal representation of rational numbers. In your 6th standard and 7th standard, you have gone through the decimal representation of the digits for the whole numbers, for the integers. And here we are going to see the decimal representation of the rational numbers. So I think you remember what do you mean by decimal representation. For an example, 3. Is there any decimal representation here? No decimal representation. So if you keep a point here, it becomes a decimal representation. How 3 can be represented in a decimal representation? By 3.0. 3.0. So keeping a point, nothing but making a number into a decimal representation. So what to do to represent a rational number into a decimal representation, we shall see here. So while representing a rational number into decimal representation, we'll get two types of values. Terminating decimal representation, terminating decimals, and second one is non-terminating decimals. So we shall consider the first one, terminating decimal. So the word here itself, terminate, means that to get an end. So what to get an end? Where there is an end? Is there any end for the numbers? We shall see here. So the first one, terminating decimals. If you consider 1 by 5, a rational number 1 by 5, I'll make a division of this. So first of all, not to represent in the decimal points, we should make the division itself. So I am making the division. So 5 here and 1 here. So divisor and dividend have put here. Now, is the division possible here? No, it's not possible. So I am giving a point here and just I am following up with 0 here. Now we'll get 5 2s are 10. And make the subtraction, becomes the 0. The null will be the remainder. What is the answer here? 0.2. So here the decimal ended with one digit. It has not repeated it. So now the answer has been ended. So there will be no repeating of the answer. That's why it is called as a terminating decimal. And you will get the clear experience of this terminating, non-terminating if you go for the non-terminating decimals itself. Now we shall see about the non-terminating decimals. Now, non-terminating decimals. and it's again divided into two types, recurring, non-recurring. So previously we have observed that terminating decimals. Now we are saying the non-terminating decimals, and this again divided into recurring decimals and non-recurring decimals. So we shall see the examples about those, then you can get the clear vision of those decimals. Among this, I'll take the first one, recurring. I'll give an example for this. 1/3. Make the division of this. Becomes 3, 1. Again, go for the decimal point. 0 here, keep it 10 here. 3 3s are 9. And make the subtraction 1 here. The division has not ended. Again, keep a 0. Again 3. Again, so it becomes 9. Again 1. Again I am keeping 0. It will be goes on like this itself. So this will be the answer, 0.3333 and so on. It is non-terminating. It is not getting an end here. It is repeating. So recurring is nothing but repeating itself. Recurring, one more meaning is repeating itself. So not to repeat it, not to continue like this, I shall just keep a bar here. The bar implies that the same digit, the digit on which the bar implies that that digit will be repeated the number of times, infinite number of times. Now we shall see non-recurring or non-repeating decimals. Now non-recurring decimals. So we shall take an example, 1/7. Now make the division. 7. The 1 does not go. Go keep a point. 7 ones are 7. Minus 3. Now keep a point. 7 fours are 28. 2 again does not go. Keep a point. 7 twos are 14. Again 6 does not go. Go for this. 7 eights are 56. Again it 4. So the answer is not getting stopped here. It means non-terminating decimal. It goes on like this itself, and it can be written as 0.1428 so on. So look at here. For this, here though it is a non-terminating decimal, the same digit is repeating in the quotient. But here if you come for the non-recurring decimals, here the quotient we are not getting any the similar value, but it is getting repeated and it is a non-terminating. So it is called the non-terminating non-recurring decimal. It is a non-terminating recurring decimals or repeating decimal. I think you get the clear about this. So what I have taught here now about the decimal representation of the rational numbers. And next, in the decimal representation, terminating decimals. Next, non-terminating decimals. Among this non-terminating, I have explained about recurring or repeating decimals. Second one is the non-terminating, non-recurring, means non-repeating decimals. I have also said about the bar. Is there any position here to keep the bar here? No, we cannot keep any bar here because the same digit is not get repeated. We are keeping the bar in the same digit only getting repeated. Now again we are going to see about it again in this only a new topic here. Students, just make all the notes of this, and this will be helpful for you in our further classes. Now we are going to observe the period and periodicity. So all these points are there in your textbooks. If you are having any doubts also, you can go through and you can refer your textbooks after the completion of 1.2 exercise. Yeah, just minute about the period and periodicity. Now we observe that 1 by 3 is equal to 0.333, which can be written as 0.3 bar. So what is about this? Non-terminating recurring decimals, and here what the digit is getting repeated here? 3 is getting repeated. That's why here the period is 3. And what the digit, how many number of digits are getting repeated here? Only one digit is getting repeated. That's why the periodicity is 1. If I take one more example, if I take 0.42, 42, 42, so on, and here the period, it is the 42, and is the periodicity is 2. The number of digits that are getting repeated is called the periodicity. So students, I think you understood about this period and periodicity. Now we shall go for the next exercise of exercise 1.3, the last exercise of this chapter.